Hi, in this video, I will explain to you on how to solve this problem. Find how much power the 2 ampere source extracts from this circuit using node voltage method. So what is the goal? The goal is find out the power that extracted by this 2 ampere current source, P2 ampere. But then the power is just the voltage multiplied by the current, right? So I will need to find out the voltage across that 2 ampere current source and then multiplied by the current that pass through this 2 ampere current source. Okay, and that is our goal, and we are asked to use node voltage method. Node voltage method, or some other book called it nodal analysis. And how to do that? Let me explain step by step. The first step that we need to do is to label all the nodes. And also extracting some information available from the circuit. Okay, maybe let's set this node here as our ground. So this is our reference node. You should always set the reference node when doing node voltage method. Some other book called it the ground, and it means that the voltage in this assumed node is equal to 0, right? But then we have 55-volt voltage source, and we know exactly the voltage here because the difference between this node and this node has to be 55, and we know that this is 0. This has to be 55 volt, right? And that is our first known node. But then we have also unknown nodes here. Let's name this node as node A, so the voltage here will be VA. And then this is also unknown nodes. The voltage here will be VB. And then the voltage across this current source is just the difference between VA and VB, right? And I think that is this one here. We have already done the first step, labeling all the nodes and extracting all the information. And the second step that we need to do is to assume the current direction, right? Assume the currents direction. Okay, for the branch with the current source, I just follow the arrow here, so it will goes down in this branch, right? But that should be, this goes to the left from VA, right? Because this is the same branch, and it will goes to the right here to VB, like that. Okay, and then what else? I think for this 4 ohm resistor, I will assume it goes down like this. And then for this 2 ohm, I think I will assume it is going to the right like that. And for this one, I also assume it is going to the right. Okay, and then we have assumed all the currents direction. We need to do the third step. We need to do KCL, the Kirchhoff current law, or the junction rule, some physics book said, for all unknown nodes. For all unknown nodes. Okay, we have 2 unknown nodes here, VA and VB. We already know this node 55, and we already know this nodes here, which is 0. So we need to do KCL at VA, and also we need to do KCL at VB. Okay, let's do that. Let's do the first KCL at VA. KCL at VA. And KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, what is the current that goes into VA? This one going out, this one going out, this one going out. So no current that goes in. So I will have 0 on the left hand side. Good. And then all the currents going out. The easy one is this one here, which is we already know exactly the value. That is 2 ampere. Good. Now what else? Let's see this current here. Okay, and that current will be plus. We need to calculate this using Ohm's law. We will have VA here, VA is where the current comes from, and then minus VB. VB is where the current goes to, right? See the arrow here. The current goes from VA and it goes to VB. So I'll have VA minus VB divided by the resistance between them, which is 4. Okay, now one more current that goes out. I will have this one here, and that current will be VA, where the current comes from, and then minus 55, where the current goes to, divided by the resistance between them. I will have 2 ohm. Good. We can multiply both sides here by 4. Why? We need to get rid all of the denominator. So we'll have 0, and this one will be 8, because 2 multiplied by 4 is 8. And 4 and 4 will cancel each other. So we will have this, the numerator, So we'll have VA minus VB. And then 2 and 4 will cancel into 2. So we will have plus 2 VA. And then minus 55 multiplied by 2 is minus 110, I think. Yeah. Okay, good. Now we will have VA plus 2 VA. That will be 3 VA. And then minus VB. And then I will have 8 minus 110. That will be minus 102, right? So we will have this equal to 102, right? 8 multiplied by minus 1 is 10. Yeah. Okay, I think that's good. Let's have this as equation number 1. This is from KCL at VA. Now let's do another KCL, but this time at VB. Okay, now let's do KCL at VB. Okay, KCL said that the sum of the current that goes in will equal to the current that goes out. Okay, let's play the same game here. The only current that goes into VB is this one. Oh, no, this one and that one. And let's start with the easy thing first. So I will have 2 ampere here. So I'll have 2. Okay, 2 ampere. And then plus this current here, I will have VA minus VB. VA where the current comes from, VB where the current goes to, divided by the resistance between them. I will have 4. Okay, and then this current here that goes out. And I will have that equal to, I will have VB minus 0 divided by 3. Okay, we can multiply this by, I think we can multiply this by 12. So we'll have 24. And then plus 4 and 12 will cancel into 3. So we'll have 3 VA minus 3 VB. And then that will equal to 3 and 12 will cancel into 4. So I'll have 4 VB. And so we can simplify things here. 3 VA minus 7 VB, that will equal to minus 24. Okay, and that is our second equation. So we have 2 equations with 2 variables. This is equation number 1, and this is equation number 2. What we need to do is to solve that equation. Solve the equations. And the fastest way to do it is by using calculator, because in the circuit exam usually you can use calculator, so why not just use that, right? Let's set our calculator here as equation solver, which is number 5. 2 variables is number 1, and I will need to plug in all the coefficients. So I have 3, and then minus 1, and then 102. Good, and now we will have 3, then minus 7, and then minus 24. Okay, we can get our PA is 41. That's good. we will have VA is 41 volt. And then what is VB? VB will be the Y value. Where is my calculator? Which is 21 volt. Okay, but the question does not ask about VA and VB. It is asking about the power extracted by 2 ampere current source. So the fifth part will be answer the question. Okay, maybe our slide is a bit full. Let's clean up our slide. Okay, what is the question asking us? The power extracted by 2 ampere current source, and that is the voltage multiplied by the current. So I'll have the voltage across that 2 ampere current source multiplied by the current of that 2 ampere current source. Okay, what is the voltage? The voltage is the difference between this node and this node, right? Because the voltage is like this, so that will be VA minus VB. Okay, so we'll have VA minus VB. VA is the one in the positive side, and VB is the one with the negative side. And then multiplied by the current, but we know exactly the current, this 2 ampere. So we'll have this multiplied by 2. Let's plug the value. What is VA? VA is 41. And then minus 21. Then multiplied by 2. So I'll have 20 multiplied by 2. So the power extracted by 2 ampere current source is equal to 41. Okay, and I think that is the final answer. We have achieved our goal. The power that extracted by this 2 ampere current source is this one here. Hopefully I did not make any mistakes in my calculation. Thank you for watching. See you in the next video. Bye bye.